In this video today, we are going to learn about photometry, which I have written here as a note. And here, like, I am also not that much, good at physics, but I'm just studying. I'm right now preparing for CEE, and I have really zero knowledge at physics. So, like, I'm starting from photometry, where I came to know about photometry. What is photometry? Photometry is the branch of optics, which deals with the measurement of light energy. And another is there are few terms about which we have to study here in photometry. So first is radiant flux. And this radiant flux is the total energy, including visible and invisible, the total energy, right? The total energy emitted per second by a light source is called radiant flux. Its unit is joule per second or watt, and luminous flux. The physical another term is luminous flux. So let's let's remember the first, the term radiant flux. What is radiant flux? The radiant flux is the total energy, that is visible and invisible energy, which are emitted by a light source is called radiant flux. I left something important. That is per second, in every second, okay? I got it again. So, radiant flux. Radiant flux is the total energy that is visible and invisible emitted per second by a light source. It's called radiant flux. And its unit is joule per second or watt. It's like the unit of power, right? So its unit is joule per second or watt. And another term is luminous flux. Luminous flux. The visible energy, as we have studied before, like radiant flux is the total energy that is visible and invisible. The both visible and invisible are radiant flux, but in luminous flux, there is only the visible light is. Visible energy is, the visible energy is included in luminous flux. So the visible energy emitted per second from light source is called luminous flux. So visible energy emitted per second by light source is called luminous flux, and the wavelength of this energy, wavelength of this light, that visible light, ranges from 3800 Armstrong to 7600 Armstrong, and it is denoted by phi, and the arbitrary unit is lumen. Arbitrary unit. It's called lumen. Its arbitrary unit is called lumen, and 1 lumen equals to 1 by 685 watt. 1 by 685 watt. 1 by 685 watt. 1 lumen equals to 1 by 685 watt. Okay. What's the so the watt? What is the unit of radiant flux? And lumen is the unit of luminous flux, which is equals to 1 lumen equals to 1 by 865 is 685 watt. 685 watt. Yeah. So another is luminous efficiency, which is denoted by eta. Okay. Luminous efficiency. Luminous efficiency is the ratio of luminous flux. Okay. Luminous efficiency is the ratio of luminous flux which is emitted by a light source and to the electrical power supplied. Okay, electrical power supply, that is input electric power, right? The electrical power supplied. So let's remember again. Luminous efficiency is the ratio of luminous flux which is emitted by the light source to the electrical power supplied. Electrical power supplied to the electrical power supplied. Yeah, yes, it indicates how efficiently electrical energy. How efficiently electrical energy is converted into visible light. It indicates that how efficiently electrical energy is converted into visible light. Yeah. So eta equals to luminous flux by electrical input electric power, that is electrical power supplied. So in another page, see wow, we are in luminous efficiency. So its unit is lumen per watt, where as we know, like lumen is the unit of luminous flux and watt is the unit of power, and as well as radiant flux as well, right? So the efficiency of fluorescent light tube light is 9%, and that of tungsten filament bulb is 3%. Do you get it? Like, it means like fluorescent tube light. When we are supplying some electrical power to fluorescent tube light, then it converts its power into visible light. 9% of its power, like supplied power, is converted into visible light, and other are converted, the remaining 91% is converted into heat energy, as well as in the case of tungsten filament bulb, only 3% of power is converted into visible light, and remaining is converted into heat energy. Yeah, that's all. So the efficiency of fluorescent tube light is more than that of tungsten filament bulb. And solid angle. Let's go to another term, solid angle, which is denoted as omega. And the solid angle is the 3D angle. Solid angle is the 3D angle formed by a surface at a point. When formed by a surface, when surface is like forming angle at a point, then that angle is known as solid angle. That 3D angle is known as a solid angle. So the solid angle is the 3D angle formed by a surface at a point. Yeah, its SI unit is steradian, which is denoted as SR. Okay, and mathematically, solid angle equals to a normal area by distance square. Okay, A by R square. Yeah, distance square is radius square, right? R square, yeah. So for a sphere, A equals to 4 pi R square, right? And when we put this value in the, solid angle formula, then it will be gonna 4 pi at the end, where R square and R square are cancelled, and the remaining 4 pi is equals to omega. That is, solid angle for a sphere is equals to 4 pi. Okay, got it. And another is luminous intensity. Luminous intensity is the amount of light a source emits in a particular direction. So luminous intensity is the amount of light a source emits in a particular direction. It means like when a source is emitting some amount of light in a particular direction, then that amount of light is called luminous intensity. Okay, so unit is candela. Let me remember. Luminous intensity is the amount of light a source emits in a particular direction. Okay, luminous intensity is the amount of light a source emits in a particular direction. Yeah, I got it. Unit is candela, CD, or lumen per steradian. Okay, lumen per steradian is equals to candela, right? Yeah, we can say like that as well. Lumen per steradian. Steradian is the unit of what? Steradian is the unit of luminous. No. Steradian is the unit of solid angle. Solid angle is steradian, and lumen is the luminous flux, unit of luminous flux. Okay, so what we just study? Luminous intensity. the unit of luminous intensity is candela or lumen per steradian. Lumen per steradian. So by definition, I equals to amount of source image. So I equals to phi by omega. Yeah, luminous flux. As we know, like lumen is the unit of flux, so mathematically it will be represented as phi by omega. Omega is the solid angle. Yeah, the ratio of luminous flux by solid angle. We will have luminous intensity. So for a sphere, I will be phi by 4 pi. Yeah. 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 Got it. That's all I studied in one day. Because, like it's really getting so heavy for me to, like understand physics. It is so like, yeah, so heavy for me. Yeah. And I'm really getting so trouble to understand physics and every, like even the simple thing. Because I haven't been like studying mathematical numericals, like for maybe 6, 7 years, I guess. That's why I just, like forwarding or, yeah, I have forgotten the things, the mathematical kind of things. So let's see, I will remember it slowly. So I'm just, like, yeah, that's all. Thank you.